Okay, what we're going to do is we're going to do problem number 17 in section 2.8. So number 17, and what we have here, it says a rectangle is inscribed in a circle of radius 2. See the figure, and what we've got here is a diagram of a circle that's centered on the origin and a rectangle that's inside that, and they give us this point x, y, and they want us to express the area of this rectangle that's fits exactly inside of this circle, and the circle's equation is x squared plus y squared equals 4. Now that's going to come into play because that's going to help us. Basically every point on this circle has an x and then a corresponding y coordinate that fits into this equation. So again, we're going to use substitution. So just think of the rectangle area first as area equals the length times the width. And in this situation, what you need to know here is that what is the width of the rectangle? Well, let's look at it in terms of this x, y coordinate here on the circle. If we, if you notice, the x coordinate is actually this length right here. So, you know, when you think about the x coordinate, say if it was 5, then that length that I just colored in there in red is 5 units. So the whole width or length, whichever dimension you want to call it, is 2x. So this side of the circle is of length 2x. The same thing works with the y, in that if you want to get the other dimension of the rectangle, this part, half of it, is equal to the y coordinate. So if y was 7, then this part of the height, or whatever dimension you want to call it, is equal to 7. So since it's a rectangle, and this happens to split it in half because it's centered around the origin, then 2y is equal to that dimension. So what this means is that we can rewrite the area as, in terms of this specific situation of this rectangle, as 2x plus, times 2y, because it's length times width, and we just showed that 2x is the one dimension and 2y is the other dimension. So that's the area, and then this other equation is going to help us substitute into this equation, because we want area as a function of x only. That means we have to find some way to substitute something in for y. And what we're going to substitute in for y, so we'll go ahead and write 2x there, is I'm going to put 2 and then a box, because we're going to substitute something into that box. And what it's going to be is it's going to be related to this function x squared plus y squared equals 4. So let me rewrite x squared plus y squared equals 4. And since we want to substitute something in for y in the box, let's go ahead and solve for y. Y squared equals 4 minus x squared. Take the square root of both sides, you get y equal plus or minus the square root of 4 minus x squared. Since we are only dealing with points in the first quadrant and we're only dealing with positive y values because we're talking about length. We only have positive length, so we're going to just stick with the positive part of the answer, 4 minus square root of 4 minus x squared. So that is what you would substitute in for y. So that's going to go inside the box. That's what's going to go inside the box. Okay, so let's go ahead and rewrite our area. So a of x equals 2x times 2 times this y, which is the square root of 4 minus x squared. And since this is all multiplication here, we can bring this out, and it would be 4x times the square root of 4 minus x squared. Alright, and so that is the area, and the next part of the question says, so that's area in terms of just the variable x, so we now express the area in terms of x only. You do the same thing for perimeter when you're supposed to find the formula for, or express the perimeter of the rectangle as a function of x. Well, the perimeter is 2 times the length plus 2 times the width. And if we substitute in the 2x let's see, 2x is the one side, so it's going to have to be 2 of those, plus 2y and 2 of those, because you're talking about 2 sides. So that's going to be 4x plus 4y, and then you need to substitute in again this square root of 4 minus x squared, and you substitute that in for y, and then you'll be done. So that's how you write those things as in a function of x only, the perimeter and the area. To graph those, you just, all you have to do is just plug that in your calculator and look at the graph. The graph of the area, it's helpful if you set your window from your x window from 0 to 2 and your y dimensions on your window from 0 to 10, and then for the largest area is when x is just about 1.41, and then the graph of the perimeter is at a maximum when x is approximately 1.41 also. Okay, and there you have it.